Okay, this is May 2008, question 7. We're given that a block of mass 8 kilograms is supported by a continuous string, ACB, that is fixed at A and B and passes through a smooth ring at C. The box is in equilibrium and the tension in this part of the string is 60 newtons. Part 1 asks us what information in the question indicates that the tension in the section CB is the same as in AC, 60 newtons. Well, the answer there is simply because it's one continuous piece of string, and so the tension in the string is going to be the same throughout the string. So this is one piece of string, so if it's 60 newtons here, it's 60 newtons there. So I can add that to my diagram. Part 2, show that the string sections AC and CB are equally inclined to the horizontal, i.e. show that alpha equals beta. Well, we know the object is in equilibrium. Now it's not moving. So that means that the forces in any given direction must balance out. So if we resolve forces horizontally, we've got 60 cos beta acting in this direction, and in the other direction we've got 60 cos alpha. Now if we divide by t, that means cos beta equals cos alpha, and the only way that can be true is that beta is alpha, given that they're both clearly less than 90 degrees. Part 3 says calculate the angle between these strings and the horizontal. So we need to figure out what these angles are. So in this case we're going to resolve forces vertically. So we're going to have 60 sine beta. Okay, check my working here. Yeah. Plus 60 sine alpha. And that, of course, is equal to the weight, which is hg. But of course we know that sine beta and sine alpha are the same thing, so we may as well call them both sine alpha. And so we've got 60 sine alpha plus 60 sine alpha, which is 2 times 60 sine alpha is hg. In other words, 120 sine alpha is hg. So sine alpha is 8g over 120, and if we figure that out and then sine minus 1 to figure out alpha, that gives us our answer that alpha is 40.8 degrees to 3 significant figures. Alright, now the final part of the question gives us a slightly different situation. It tells us that we have a box of mass 8 kilograms and it's supported by 2 separate strings. We have a string here which makes an angle of 45 degrees, and we have a string here which makes an angle of 25 degrees, and we have a force of 10 newtons horizontally, and clearly we've also got the weight of the block, which is mg. So we'll call the tension here T1 and the tension here T2. We need to use 2 separate letters for the tensions because these are 2 separate strings, and so there's no reason to suppose that the tension in these 2 strings is the same. It could well be different, and it probably will be different because of these angles. So we need to figure out what these tensions T1 and T2 are. So the standard method is to resolve forces horizontally, resolve forces vertically, and use those 2 equations to find T1 and T2. So if we resolve forces horizontally, we have T2 cos 25 minus T1, plus 10, okay, minus T1 cos 45, and that must equal 0. There is no resultant force. You may have written that on the other side. And then resolving forces vertically, we have T1 sine 45 plus T2 sine 25, so that's in this direction, minus hg equals 0. Now we can do some calculation there. We could actually work out what cos 25 is as a decimal, and cos 45, and sine 45, and sine 25, and we could figure out what 8 times 9.8 is. So we could simplify these 2 equations to produce 2 simultaneous equations in T1 and T2, and then the best thing to do would be to use your graphics calculator to solve those two simultaneous equations. And if you do that, you get the answer that the tension in this section, which is T2, is going to be equal to 51.5 newtons to 3 significant figures, and the tension T1 is going to be 80.1 newtons to 3 significant figures. And that's the end of question 7.